Well, welcome back. We're back doing some more Common Core Geometer Sketchpad. Right now we're looking at Module 4, Lesson 3. That's on page 30. And we're looking at example 1. So we're going to go ahead and construct that rectangular region with a point at 1, 2, and another one at 15, 7. So we'll just go ahead and we'll construct a rectangle with those. So I'm going to turn on that grid. And then we'll just go ahead and plot some points. Just I think that would be the easiest way to get exact points that'll always stay there. So we need point 1, 2. We also need point 15, 7. We'll have to change our display to see that. Then we'll also need point 15, 2, so we get the rest of the rectangle. Might as well just put that in. And we'll put in point 7. All right. Oops, that's that. Oh. Oh, come on. All right, sorry about that. I had so many things open. Here, almost crashed on me. So we'll pick it up. We were using the polygon tool, and we're just going to connect both these points and make it a rectangle. So now we can see where the area that is. And I think we're also just going to connect the outsides. We'll connect them with these segments. That way we put points on them, in them, whatever it requires us to do next. All right, so there we have our rectangle. Maybe we'll even display. All right, good. So does the slope of line 2 passing through the origin intersect with this region? All right, so we need to draw that line. Okay, next up it looks like it's asking us to draw a few lines with different slopes passing through the origin. So rather than draw a bunch of lines, I'm just going to go ahead and make a number, a new parameter. I'll call it M for slope, and it starts out at 2. So we'll do that. So that'll show up over here. Sorry, my plan is to change that when we're drawing new lines. So since I have that selected, I want to go ahead and do a graph. We'll plot this function. And we'll use the y equals notation, that's fine. And we want to use m, since I have it selected there, and times x. And since it passed through the origin, we don't need anything else, so we'll say okay to that. So there we have our line y equals 2x. So does the line intersect the rectangle? Yes. And which boundary points? So it looks like this boundary point, and we can actually calculate the intersection there and get that point if we wanted to. Without looking at the rest though, just to show you a little trick we can use here. So the next one is asking me for change the slope to a half, so I'm just going to put in the 0.5, and now we have that slope of a half, and you can see it intersects in 2 points. Also, again, we could also find those points. We could label the abscisses, and in the graph menu, in the measure menu, it'll actually show me coordinates of points if we needed to do that. We have 1/3, so we could go ahead and do all of those, which was M. That's through the region. So we can go ahead and do a lot of the rest of those. So just wanted to set that up and keep the video brief. If anyone did want to see where we did those intersections, I guess we could just do that part. So let's select here, select here, and this line perhaps, and we'll construct the intersection. We probably should have done it here too. Construct that intersection. And we should be able to click on these and measure those coordinates. So there they were for that one. An idea, depending on what they want to do here,